So to finish the lecture on glass, I want to look at the legacy of the Crystal Palace, this one project that synthesized all the advances in iron construction and, as we've seen, in glass construction up through about 1850. And to look at what this one building really did for the construction industry, the discipline of architecture, and how it inspired or led to new ways of thinking, new things that could be imagined, right? There's a phrase called thinkability. What do our brains allow us to imagine based on what we've seen? And the Crystal Palace, I think, is a great example of kind of raising the bar on what humans thought was possible to build. So 4 sort of things to look at as its legacy. One is the idea that not only could you build such a thing of iron and glass of such profound kind of lightness and scale and so quick, but also that the aesthetics that derive from it, the very, very lightweight skeletal iron, the huge spans of transparent glass, were all part of a debate over what constituted architectural beauty, right? And I think set the tone in some ways for a lot of the debates about modernism that we'll touch on briefly when we get into the 20th century. As far as the industry goes, it certainly made the case for prefabrication. As impressive as the Crystal Palace was as a noun, as a building, as a thing, it was maybe even more impressive as a process. And the amount of prefabrication that went into it, the amount of thinking through the industrialization of the fabrication process, of the transportation, of the assembly, all of these are things that we've talked about in various forms as kind of manual processes. But these, here at the Crystal Palace, we really see a new way of thinking through the production of building. And this is something that will, of course, be very important in the late 19th and throughout the 20th century. It's a kind of paradigm setter for iron as well as glass, that iron was a legitimate structural material, that it could be used not only for mill construction and bridges, but for large spans as well. And the Crystal Palace as a building type, as a world exposition, set a very high bar for a number of these expositions throughout Europe and eventually North America that offered an inherent sort of architectural and engineering challenge to each country that held one of these expositions, right? Can you build larger than the Crystal Palace? And then can you build larger than the country that went right before you? We'll start there and look right away at what America's response to it was. America's response to the Crystal Palace was, in fact, to build a Crystal Palace. And New York held an exposition in 1852 where they built a glass structure that, as you can see, aped the best parts of the Crystal Palace, but in some ways sort of lost their nerve and added things like domes and more fancy entrances and things like that showed maybe the nervousness of a nouveau riche nation, right? But this was the largest glass building in North America, certainly not anywhere near the size of London's Crystal Palace, but nevertheless it shows just how influential not only the building was, but also the process. New York built this within a year of the Crystal Palace's opening, so it showed that this was possible as a process in addition to as a product. And you can trace the lineage of World's Fairs and expositions right up through the Paris Exposition of 1889. We looked at this building, and we also looked at the tower that went with it, the Eiffel Tower, as examples of iron construction. But if you look, you can see, too, that there is plenty of glass bringing daylight in through the roof and showing off the machinery of countries of the world in bright daylight. And this, of course, was the most efficient way to illuminate a space that large. Electricity was still a very young and very expensive technology. And so transparency was important to bring in natural daylight into these exposition halls. And there are sort of versions of this that get built throughout the world as market halls. The ferrovitreous legacy is probably most widely spread in these very functional structures that had, again, to span very large spaces so that carts, and wagons could move around, but also had to bring in a lot of daylight and often had to be designed for natural ventilation as well. So lightweight roofs composed of operable glass panels that could be opened or closed based on how smelly things were inside or how hot or cold it was outside became an important component of market halls. And these sprung up first throughout Europe and then throughout North America and gave architects sort of many opportunities to experiment with the architectural possibilities of iron and glass. And these are both images of the great Parisian market Les Halles, which was built, as you can see, almost contemporaneously with Crystal Palace, sort of just after it. And if you look on the right, you can see the kind of arched cast iron prefabricated bays that are a direct copy, basically, of the Crystal Palace. So not only a precedent in terms of constructive type, in terms of long span function, but also very clearly an aesthetic prototype and one that was copied in many ways. The sort of fancier end of this, and in some ways maybe the more impressive structurally and urbanistically, was the use of glass, often coupled with iron domes or vaults to form arcades. And here you see two in Italy, one in Milan on the left, where the relatively cold winters made enclosing the streets of this block of Milan. It makes sense climatically. On the right, similar thing in Naples, where buildings are built framing existing streets, and then arcades were built over them to provide shelters. In many ways, these are the first enclosed shopping malls, and they happen only because of the ferrovitreous type that was pioneered by the Crystal Palace. And glass and commerce go hand in hand throughout the late 19th and early 20th century, particularly in storefronts where the need to show off the product is something that is sort of inspired by the technology. We don't see huge storefront windows in early 19th century retail construction. We see it only come about after industrialization of glass makes it affordable. But once it's affordable, it becomes a completely standard element to retail construction. This is the Piccadilly Arcade in London, so again, picking up on the British tradition of glass. And you can see that the glass allows all of the shopkeepers in this arcade to show off their wares in a way that simple masonry construction wouldn't. And you can see, too, that by this point, only 50 or 60 years after the Crystal Palace, there's a very sophisticated technological ability with glass. These are curved cylinders of glass that are relatively hard to manufacture. That requires another slow firing process to heat a sheet of plate glass, to melt it or drape it over a mold, and then to remove it, all while maintaining the proper thickness and not thermally shocking the glass while it's heating and cooling. So the sort of industrial craftsmanship of glass is clearly something that has improved over the last 60 years. And it's not just retail. Glass becomes a ubiquitous presence in high-rise building skins in the 1890s. And when we talk about skyscrapers, we'll talk briefly about why glass was a particularly important material to Chicago skyscrapers, like the Reliance building here that you see on the right. But it was also used generally throughout commercial construction, office construction, because again, until the end of the 19th century, electricity, while it became relatively common in offices, remained expensive and remained difficult to use until the tungsten light bulb was perfected in around 1910. So windows are still the best way to illuminate offices. And here in the Reliance building, famously windows of about 6 by 7 feet that brought light into what were suites for doctors' offices in downtown Chicago. Daniel Burnham, writing about glass a few years earlier, talked about it in ways that not only anticipated the Reliance building, anticipated the glass skin, but also began to hint at the more sort of emotional or even spiritual possibilities of glass. Here he is talking to a local architectural audience in Illinois. And he foresees both that glass will eventually be cheaper than good building stone, As we'll see, it became even cheaper than brick in Chicago in the 1890s. That it allowed for speed of construction, can be built more quickly into place inside or out than stone. That it's a cleaner construction process. You're not relying on mortar, which can be mixed improperly or placed improperly. And that is, you can clean it, right? The ultimate of cleanliness is obtained. If you think back to the 1890s, this is an era when typhus and cholera and all sorts of diseases were threatening cities, especially, and hygiene was particularly important. And then you can see, too, that Burnham talks about the aesthetics of it. Not only flat, even surfaces, but depth and consequent richness can be obtained for decorations. In other words, the transparency of the facade allows you to think about depth and shadow in ways that simple stone doesn't. And then here, the last bit, this is, I think, the element that gets picked up on by later generations. Glass is both a sanitary, hygienic product, but also one that has these almost kind of miraculous qualities. Not only is it transparent to light, but impermeable to air. But because it is so smooth, it can be kept very clean, and that will save us from, as Burnham says, disease and the seeds of death. And it's hard to overestimate the importance of this, the importance of glass as a sort of sanitary material. That will get picked up on here in a few years after Burnham speaks by a series of German architects in particular. That's not to say that everyone agreed. Here is a New York critic, Bar Ferree, talking about the Reliance building and basically saying that its aesthetics are kind of terrifying to people used to stone construction. The Reliance building is the most notable attempt yet to reduce the amount of enclosing material to the minimum. The result, he says, is scarcely more than a huge house of glass. The Reliance, the Fisher building, also a Chicago building, and the Mabley building in Detroit show this as well. And Ferree complains that the building should not only be firm and strong, but that it should seem so or look so. And these early glass skyscrapers, he thinks, look far too fragile to be reproduced in urban settings. He thinks they'll terrify people, and he also thinks that it's a sort of debased aesthetic. So glass is controversial. There are those who are huge fans of it and think that it is going to be transformative in architecture, Burnham among them. There are more conservative critics like Ferree, and as we'll see in a couple of weeks, the art critic John Ruskin. Ruskin looks at the Crystal Palace, remember, and puts a hold on a book that he's publishing to write a scathing indictment of the Crystal Palace's aesthetics. And here I think we can get a sense of the reactions that permeate the 20th century and even today. The question of whether expressive technology is a worthy aesthetic of its own, or whether it so violates our traditional senses of aesthetics that we should cover it up, right? That we should hide it. This is a debate that will continue and continues to this day. What sort of puts the debate to rest, though, is the fact that glass gets cheaper and cheaper. Burnham is absolutely right. The technology is on the horizon that will make glass cheaper not only than stone, but cheaper than any other enclosing material as well. Some of those mechanical processes happen in France, the so-called Buchereau and Fourcault processes, which are very similar to processes developed by the American glass manufacturer Libby Owens Ford in 1916. And here you see that the secret to both of these is to automate the handling process, to bring glass out of the furnace as a molten ribbon and to find ways to let it cool naturally so that the end result is very similar to the polished plate that we saw coming out of the furnaces on polishing and grinding tables in the 1880s and 1890s. Here, as you can see on the right, the glass that comes out of these rolling processes is much cleaner. It requires much less in the way of polishing. The way that both of these worked is to basically dip a wick into a reservoir of molten glass and to then pull that wick through either on the left, you can see the Fourcault process, which is a series of increasingly fine rollers that give you a guaranteed thickness of glass, and as the rollers get finer and finer, a smoother and smoother product. On the right, you can see the LOF process. The only difference between the two is that the LOF process comes out horizontal and is pressed together through a pair of belts on either side that also give it a reasonably smooth finish, one that still has to be polished, but that gets a long way toward the grinding that had to take place on raw polished plate in the 19th century. With these processes, with these automation, the manufacture of glass, these save time, they save labor, and therefore they save an enormous amount of cost. And this makes glass no longer a luxury item, but really a genuinely affordable building material. It appears in commercial construction, in stores, on offices, not so much in residential construction in the early 20th century, but it will in the 1950s especially. And this kind of flowering of a new material, right? You remember that iron was really the first new material in centuries in the 18th century, the first newly affordable material. Glass is really the second. And architects in the early 20th century look at this material, one that's been familiar but is now available in much larger pieces, much cheaper pieces, and they begin to speculate on what a glass architecture might look like. This happens particularly in Germany. On the left, you see a sort of shrine or a spiritualist temple by Bruno Taut that uses these large diamond panels of glass as a way to sort of concentrate solar energy in a way that Taut thinks is going to be healthy. On the right, a slightly more sober use of glass in Walter Gropius's Deutsche Werkbund model factory in 1914. And you can see that he is using glass as a kind of metaphor for the machines that he sees being made in the factory, showing off its sort of smooth, polished surfaces as technological analogies to the machinery that's going on inside. And also, as you can see, showing off the architecture, transmitting what is inside the building to outside eyes. So very much as Burnham thought that the glass's transparency would allow new ornamental effects, here you see this idea of transparency in the sense that the building's skin can now just transmit the logic of what's going on inside. And maybe nowhere is this more evident than in two projects by Ludwig Mies van der Rohe, one of the most important architects of the 20th century, who here in purely theoretical projects proposes glass skyscrapers for the central city of Berlin on the left, and a more suburban location on the right. And we will come back to these images a couple of times in the next few weeks, because they really sort of set an ideal that the technology of glass and of concrete and steel and elevators and lots of other things are not quite up to in 1922. But they show that architects are thinking ahead, and that instead of just putting means toward functional ends, they're thinking about the architectural possibilities of these new technological materials as well. The ferro-vitreous tradition takes many forms. This house by a Parisian architect named Pierre Chareau in Paris shows that the aesthetic of raw steel and raw glass is becoming more and more acceptable in all sorts of environments. So this is both a medical office and a residence. And you can see that Chareau is very content to let both the bolted steel that you see on the left and on the right, the industrially produced glass he's taken a type of glass that's usually used for factory construction and used that to construct this giant double height glass facade for the house. And here we see that industrial aesthetic being used in a residential environment. I think if you contrast this with some of the aristocratic British houses that we looked at in the early part of the lecture, you can see that glass remains a status symbol, but here it's almost a reverse status symbol, right? The kind of roughness, the industrial nature of glass is what's being celebrated instead of its sort of pristine nature. So this material is kind of perfectly suited for the 20th century. It both inspires architects toward new forms, toward new experiences, but it also allows for much higher building function in terms of daylight, but also in terms of transparency and in terms of speed of construction, among other things. In this sense, it's a truly high-performance material, so very much like iron performs much better than brick. You can think of glass as performing much better than brick in other ways, right? In what it does to the facade and what it allows in terms of the interior. As we've seen, it creates an entirely new aesthetic. Architects look forward to being able to use it in ways that are hard to imagine in the era of the Crystal Palace. And it continues to allow for a great deal of prefabrication. Now the cladding of the building can be manufactured in the factory offsite, parallel to the foundation work and other things that are going on site. And huge amounts of area can be assembled on the building at one time. So one large sheet of glass can take the place of several dozen bricks and can be, as you can imagine, much speedier and much more cost-effective in terms of labor than asking 5 or 6 bricklayers to lay that cladding panel instead. As a technique, it has problems. We know today that glass is a terrible insulator, and that also it can not only let in enough daylight, but it can let in far too much daylight. But it also sort of troubles architects as a metaphor, right? What does it mean to have a building that is transparent? And what do you show off when you open up the facade? We'll see architects sort of struggle with this throughout the 20th century. And it also, I think, plays a key role in one of the great themes of the late 19th, early 20th century, and that is that we've gone from thinking about exterior walls in masonry construction as elements that support the building, right, that are structural elements. Well, now the iron has allowed us to support the entire building on a frame, and glass's thinness and its light weight allow us to think of the exterior of the building not supporting the building, but just enclosing it, right? Removing the structural function from the outside, and therefore freeing up the exterior to be a much, much different architectural expression. What that expression is up to architects, and it is an amount of freedom that is maybe difficult to deal with at first, but it also presents amazing opportunities in terms of rethinking what it means to design a building, right? What we want to show off instead of just a composed, solid facade. And we will get to the point where we look at buildings that finally realize Mises' ambition of a completely glass-clad, in this case, if not skyscraper, at least 3-story building. The history of 20th century architecture is very much tied up with the continued improvement in glass fabrication, in glass materiality, in glass performance, and in glass construction. And a lot of what we look at over the next few weeks will be tied up exactly in how glass goes from, as we've seen, a luxury material to an industrialized material, and we'll look too at steps where it becomes a high-performance material and one that is absolutely ubiquitous in all types of building construction, from small residential houses up to the largest possible skyscrapers.